All right, let's take a look at numbers 1 through 5 here. So first of all, the flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. And again, that's the flow. So that's a rate of change of the following, which best approximates the total number of barrels of oil that passed through the pipeline that day. So anytime they talk about the total numbers, what they're asking for is the area under that curve, really. So notationally, it would say, hey, what is the integral from 0 to 24, okay, because this is per hour, so 0 to 24 hours, of this function, whatever it is, f of x dx. So they want to find the area under that curve. So I can look here and say, well, first of all, this section right here, if I went straight across, this section right here is a rectangle that's 24 long, 100 tall, or thereabouts. So this is about 2,400 right here. Okay. Clearly, we get bigger than 2,400 because we have that hump there. So 600 is definitely out. 2,400 is definitely out. The question is whether we get to 3,000 or 4,800. So the way I kind of look at it is if I take this section right here and pour it into this section over here, we're going to just about fill a square. So one square is what? 6 wide, 100 tall, so it's about 600. So total, we have about 2,400 plus 600, which is about 3,000. Now, it could be a little bit under, it could be a little bit over. Technically, I would say it's a little bit under 3,000 because of the fact that this square does not quite get to 100. So this is under 2,400. And we can see here, I would say that this would constitute just a little bit or just about half of the square. So that would be the other half. So that's about 600, but there's no way we're getting up to 4,800. Again, it's an approximation, but usually the right answer is far enough away from the wrong answers that you can confidently choose, in this case, the 3,000. Number 2, the graph of the function consists of 2 line segments as shown in the figure above. The value of the integral from 0 to 3 of the absolute value of f of x dx is. So this again saying what's the area under the curve of the absolute value of f of x. Now, absolute values just basically make things positive. So it says take this entire function and make it positive. That means this piece here that goes down underneath would actually come up here. So the rest of the function would stay exactly the same because it's already positive. It's just that once it hit 2, it would bounce back up and end up here at 3, 1. So then let's find the integral by finding the areas. So what do we have? We have a trapezoid here, and we have 2 little triangles. And you might be able to safely say that these 2 triangles are congruent, so I can find the area of 1 and double it. So let's talk about the area of the trapezoid plus 2 triangles. Formula for trapezoid is half the height times the sum of the bases. And the triangles is half base times height. The height of a trapezoid is the distance between the bases, where the bases are these parallel sides. So the height here is 1, and my bases are 1 and 2. I can up here just cancel the 2 times the half. The base of this triangle is 1 times the height is 1. So I get half of 3 plus 2. So I get 3 halves plus 2 is, I'm sorry, this is 1, not 2. And 1 is 2 halves. 3 halves plus 2 halves is 5 halves. Number 3, the graph of the function f is shown above. What is the value of? And again, same thing, just finding the area from 0 to 7. This time, notice it's not the absolute value. So this area down here, I've got to remember, is negative. So again, we're going to split this up into trapezoid. This is actually a square, 2 by 2, triangle, and then a negative triangle. So we've got a trapezoid plus a square plus a triangle. And then what I'm going to do is this. I'm going to go minus we'll call that triangle 1 minus triangle 2. So trapezoid, 1/2 times the height is the distance between the bases, that's 2, and my bases are 1 and 2. This square is a 2 by 2 square. Triangle 1 has a base of 1 and a height of 2. And triangle 2 has a base of 2 and a height of 2. Now, if you want, you could just say plus triangle 2 and then maybe make the height of the triangle -2 because it goes down. Either way, it's still going to come out to negative. So 1/2 times 2 is 1, so I get 3 here in the first term, plus 2 times 2 is 4, plus 1/2 times 1 is 1/2, times 2 is 1, minus 1/2 times 2 is 1, times 2 is 2. 3 plus 4 is 7, plus 1 is 8, minus 2 is 6. All righty. Number 4, the graph of the function shown below. From 0 to 3 of the following, which has the least value. And there's your left, right, midpoint, Riemann sums, and your trapezoidal sum. Now, the first thing to make sure is that all of these are the same, that they are the integral from 1 to 3, check, of this function, check, with 4 subintervals, check. Otherwise, if you have different number of subintervals, that could change. If you're doing area from 1 to 2 versus 1 to 3, that could change. So the first thing to look at is this. This function is decreasing. If the function is decreasing, that means the right Riemann sum is an under approximation. And it means the left Riemann sum is an over approximation. Because this is concave down, then we know the midpoint Riemann sum is an over approximation, and the trapezoidal sum is an under approximation. And again, that goes back to that page that we had, that we did it, we graphed the 4 graphs. So make sure you look at those and learn those, either memorize them, or if you can kind of picture what's happening in each of those, sometimes you're able to figure them out in the problem. So of the following, which is the least value? Well, anything that's an over approximation is automatically out. So we can't do a left Riemann sum or a midpoint Riemann sum. So now the question is whether the right or the trapezoid. Well, remember, the way it works is this, okay? Whether you have left and right or right and left doesn't matter. The trapezoidal sum is always going to be between them because this is the average of the left and right Riemann sums. So therefore, if my right is an under approximation and trapezoid is an under approximation, then the trapezoid must be greater than the right Riemann sum. Therefore, the right Riemann sum must have the least value. And then number 5, the table above gives selected values for the continuous function if f is increasing over the closed interval. Which of the following could be the value of the integral from 0 to 3 of f of x? So there's a few different ways of doing this one. I'm going to go ahead and open up a new sheet just to show you. You're not going to be able to see the table, but you have it, and I'm going to use those numbers. So what we're going to do here is we're going to start with a left Riemann sum, and I'm just going to go do all of the intervals. So we're going to have an interval width of 0.5 times 0, that's the first height, plus 0.5 times 4, plus 0.5 times 10. And each of these intervals has a width of 1/2, so I can just plug in the 1/2, and I just need the next height, which is 18, plus 1/2 times 28, plus 1/2 times 40, and that would be the last left interval. So 1/2 of 0 is 0, plus 1/2 of 4 is 2, 1/2 of 10 is 5, 1/2 of 18 is 9, 1/2 of 28 is 14, and 1/2 of 40. 14 and 9 is 23, 23 plus 5 is 28, plus 2 is 30, plus 20 is 50. All right, for the right Riemann sum, it's still going to be a width of 1/2, but now we're going to the right interval. So that's going to be, the first height is going to be 4, the second height is 10, the third height is 18, The fourth height is 28. The fifth is 40, and we add on that last piece, which is 54. Just as up above, these numbers are the same. So I have a 2, 5, 9, 14, 20, and 27. This piece here from up above gives me 50. We just did that calculation up here. Plus 27 is 77 for the right Riemann sum. Because this is increasing, I know 50 is an under approximation. I know 77 is an over approximation. So therefore my answer must be between those two values. So therefore 62 is the answer. The other thing you can do is you can average the two. 50 plus 77 divided by 2 does give me 63.5, which is a closer approximation. That's the trapezoidal sum. So either way, we see that we get an answer of 62. Okay. Look out for the second video where I'll go over numbers 6 through 10.